Yes. Let me see if I can find a slide. All right, so welcome to this session, which is a discussion panel. And the title of our panel is Ethics and Explainability in Climate AI, from Theory to Practice. I am very excited to be here with you. And our panel is hybrid today. So I'm going to introduce myself and then move on to our panelists for a brief introduction. So I'm Viviana Acquaviva. I come here from the City University of New York, this year at Columbia. I work in astrophysics and AI for several years, and as of last year, I decided to transition my research focus to climate science. I'm supported by a Pivot Fellowship from the Simons Foundation, and Galen, McKinley, and Pierre Gentine are my mentors. And I'm working on custom metrics to evaluate similarity in climate maps, on reconstructed PCO2, global PCO2 field in the ocean from sparse data, and in ethics and explainability. And I'm also hiring a postdoc, just in case. If you're looking, please come and talk to me. I'll go to David John here, and then we'll go to our online panelists.
All right, good morning, everyone. My name is David John Gagne. I'm a machine learning scientist too, and head of the Machine Integration and Learning for Earth Systems, or MILES group at the US NSF National Center for Atmospheric Research in Boulder, Colorado. My work focuses on machine learning for all kinds of different weather and climate applications. Most recently, we've been doing a lot of work with machine learning emulators, from full AI NWP emulators to process-based simulators, including one we're currently working on trying to get into the community Earth system model. We also done a lot of work with explainable AI and trying to understand physics of explainable AI, as well as how can we explain uncertainties and link those uncertainties to physical processes. Related to this talk, I'm also a co-author on a paper that was in the first issue of Environmental Data Science on ethics and biases in AI for environmental science. So happy to talk about that more today.
So I think we can officially sit down, and maybe is it possible to show our online panelists. Hello, everybody. Do you mind saying a couple of words? Maybe I see Savannah first on screen, and then Libby and Galen. We want to go in that order.
Great. Hi, I'm Savannah. I'm a research scientist and adjunct professor in the Data Science Institute at Columbia. My background is originally in physics and particle physics, and I work broadly now at the intersection of machine learning, physics, and ethics. So I teach our AI ethics class at Columbia, and I'm generally interested in questions on how we can use physics physics and climate as a sandbox to learn more about how to make machine learning more robust and trustworthy.
All right, good morning, everybody. My name is Elizabeth Barnes, or Libby, so I'm a professor in atmospheric science at Colorado State University. So my training is as a climate scientist, but then I have sort of slowly morphed into this world of machine learning, specifically for Earth system science. So I sort of think of myself as one foot in both camps these days. I think a lot about climate prediction across time scales. So from anything sort of beyond that weather time scales all the way out to, so 1 week or so, all the way up to decades. And a lot of the work we do thinks about explainable AI and interpretable AI, or building AI models that are sort of interpretable and understandable by a human from start to finish. So we put a lot of our emphasis not just on using it, but also understanding how it works, not just for sort of the ethical reasons, which is why we are here today, but also to actually learn new science about the Earth system. And so I think those two things go really nicely together. And I will hand it over to Galen.
Hi, good morning, everyone. My name is Galen McKinley. I'm a professor of Earth and Environmental Sciences at Columbia University, and my research is on the ocean carbon cycle and its role in the global carbon cycle and thus in climate. So for the past 5 years or so, I've been pursuing one track of research in my group on using machine learning to interpolate very sparse ocean data to understand how the ocean carbon sink is operating on monthly timescales and making predictions into the modest, near real time, we call it. And definitely physical constraints is an important part of that. And I've done a little bit on explainable AI as well. And in the past several years, I've also been a deputy director of a National Science Foundation funded science technology center called LEAP, which has the goal of bringing machine learning more broadly into climate models and climate prediction. And we're working closely with David John Gagne, for example, at NCAR and others at NCAR to try to do that. And the goal there is to really make predictions for the next 40 years and also to educate climate data science workforce and to do knowledge transfer, which carries the information towards nonprofits, public, and also to the private sector. So that's my involvement, and I'm really happy to be here today to chat more about climate and AI and ethics. Thanks.
Wonderful. Thank you so much to our panelists. As you can see, this panel spans several fields of expertise, also several time zones. In Colorado, where Libby is, it's about 4:25 a.m. It's 6:25 in New York. It's lunchtime in Switzerland, where Galen is at the moment. So I feel like, I'm very grateful to our panelists for our willingness to chat with us about this topic at these times. So I'm going to say just a couple of words about, how this panel came to be, why I proposed this panel. And so for me, there were these two sort of big moments. One is I read this book by Luciano Floridi called The Ethics of Artificial Intelligence. And an idea that really stuck with me was the idea of thinking of AI as a form of agency rather than intelligence. And so thinking about, like an actionable item or a system to study. And the book, like many of his works, also presented a framework of these 5 principles for AI, which certainly is not maybe it's it doesn't list everything, but I feel like it was a good starting point for me to start thinking about, okay, how do I make this practical? And the other big moment was actually when Savannah, one of our panelists, came to guest lecture in one of my grad classes in ML for Physics and Astronomy. And she introduced me to this paper called The Fallacy of AI Functionality, which talks about, again, AI as an infrastructure or system, and proposes the idea of looking at all the many ways in which AI systems can fail as a guidance for how we can do better and how we can introduce ethical principle in our scientific practice. And to me, this felt much less overwhelming and more actionable than thinking in general about ethics or governance or regulation had felt. So my goal, my hope for today is that we can sort of talk about this ethical principle or challenges and connect them to our everyday practice of scientific inquiry. And clearly this is not exclusive to AI systems, but I do believe that AI systems sort of add a level of opacity, right, to this process. And I'm hoping that we can do this perhaps through the lens of functionality and I don't know, I think I had another little bit that said explainability, and to reflect on the role of explainability in making this process. So we have, I think, 4 questions that we have proposed. We are running a little late, so we're gonna maybe try and spend about 8 minutes-ish on each of them, because I really would like to leave some time for questions from my audience, especially, but of course not only our early career community members, to think about, do you think about this? Do you think it's relevant? What do you think we could do better? So my first question, I realized that I have this talent for writing questions that are unnecessarily complicated. So the first question that I wrote was, what are the most relevant ethical principles or questions in your area of scientific expertise? Which is another way of saying, where do you think ethics pop up when you do science on an everyday basis? And so I don't know how we're going to start. DJ, do you want to take a stab at this first one? And then we'll also move on to our online panelists.
Yeah, I can take I'll take a first quick stab at this. I think one of the big relevant principles is like first figuring out what is the question that you're trying to ask. And often, I think in AI problems, we kind of jump to, like we have our favorite model and we want to try that on some data, the hammer nail problem that I think people are familiar with. Or also like even just stepping toward what is the convenient data set, what is the convenient benchmark. But often, like when actually applying these models in real world settings, like there's a lot of ways to frame the problem, and one really needs to have a connection with their users and other developers and domain scientists to actually get a sense of like what are the important problems, what are the important constraints on those problems, what's already been done in that area before kind of jumping into the whole just like throw an AI model at it and see what happens. And so like I think a key part of this is just like getting to know your community, getting to know their needs and what they consider important, and also what they consider maybe not important. You may be sometimes finding that maybe you're spending all the time trying to get another 1% accuracy in the model, and sometimes it matters, sometimes it doesn't. We through our AI2ES AI Institute that I'm a part of, we worked with social scientists who basically on interviewed forecasters, and one of the things the forecasters understand is that the models aren't perfect. They know that the current NWP models are not perfect by any means and have their own artifacts and weird non-physical things that happen in them. But if they know about them and have experience with them, then they can kind of filter that out and use other sources of information to help them guide them toward what is more likely to be the most likely outcome. So I would say, yeah, communication early and often, and understanding your users, understanding the context in which they're working, and what is important for them is pretty critical.
Thank you. Online panelists, we see all of you, by the way. You are with us in the room, even if not. So yeah, anybody who wants to, yeah? Livy, please go ahead.
Yeah, so thinking about this from a climate modeling, and Galen's a climate model expert, but just more of the use of climate model data and how we're using that information. A lot of these models are meant to serve the entire international community, right? Not just one specific question. So I'm going to take David John's example and flip it on the other side. And when you do that, you start having big questions like, what is a good model? So when we start training on these climate models, who decides what good is? Because these are not tools that are meant for one purpose. They're going to be used for many, well, the hope is that they'll be used for many questions, for many communities. This starts to bring up questions of how and where these climate models were developed to, say, serve as training data. Where did the observations and the observational constraints come from? There's a huge imbalance across the globe of measurements and where they're located. Even the process of tuning these things, right? Let's say you're trying to tune an AI model to do global precipitation, right? You know, where the builders, where the AI expert is coming from can be a place they focus on. I'm in Fort Collins. I'm going to look at Colorado, right? Because that's the place I know. And so those can bring up really big issues, especially again, when the tool is meant to serve many, many different people. And then I'll just, maybe this will be my running thread through some of the questions. But I think a lot of the topics we'll probably talk on today are not necessarily specific to AI. You know, that my statements about the climate models were true back also when they're physics-based models. Where does the data come from? How are we tuning it? But I think AI is really bringing this to the forefront in our community in a way that many of us never, at least I'll speak for myself, that I never really talked about before. So I see this as a good thing. It's opening a conversation. And it's sort of giving our community a kick that, hey, you can't ignore this any longer. And so I hope that these sorts of discussions start to bleed backward into the other ways we do our climate science, not just the AI piece. I sort of took your question and twisted it there a little bit, but
No,
all right,
that's
I'll
what-
pass it on.
That's exactly what I would hope that you would do. So yeah, I think this is great. Galen.
Yeah, I want to really echo what Libby said there. I am thinking about the panel and what I was going to say. I really think that, this is a valuable opportunity for the climate science community to think about ethics in a way we really haven't. I mean, I know that in some of the early internal grant applications I did to the Data Science Institute at Columbia, there's questions about ethics. And I was like, well, that's just not applicable, right? Because this is climate and it's obviously for good. I think that is probably for the most part in climate science, the way people are thinking about ethics now. And I think that we need to do better and think more. I completely agree with Libby about these issues of data representativity and who's building the model. I think it's just also really important to think about the fact that, the IPCC process on climate models, the ethical approach is really everyone's climate model is equally good as anybody else's, right? And there isn't a lot of application of metrics for performance before you use it in terms of making a mean and understanding, what's global temperature going to be like in 30 years. We just assume that the mean of all the models and their spread is the best estimate. But that might not really be the best estimate, but it is politically easy. Is that also ethical? And then the last thing I wanted to just add there is that, I think increasingly in our climate science world, really just in the last few years, in part with AI, but not exclusively because of AI, there's an increase in the kind of privatization of climate information in a way that did not exist, I would say, 5 years ago or so. And so I think that's, on the one hand, probably a good thing, to hopefully getting more climate information into the hands of people who can make decisions. I think the only way we're going to scale the applicability of climate information to all the decisions that need to be made on the planet about adaptation and mitigation is to have private sector heavily involved. But we need to recognize that there are ethical implications about, the potential to concentrate power in a few hands, maybe not make this information available to everybody who needs it. And I'm not saying I know what the answer is, I'm just saying we need to be aware of this when we're working and not just sort of blanketly assume that, I'm doing climate science, obviously it's good, and there's no ethical concerns. Thanks.
Thank you, Galen. Savannah, do you want to go next?
Yeah, so I'm maybe going to speak first from my sort of angle as a physicist. I have borrowed a lot of ways that we think about model building in pure physics and applied them to how I think about building trustworthy AI. So one of the things I talk about a lot is this idea of phase space in model building. And really, this is a problem that I see in building AI for science and AI for really any kind of application area, is that often we don't spend the time to necessarily understand the entire phase space of where we want to apply a model. So thinking about edge cases, thinking about the distributions of your data, making sure that you have enough a representative data set, and then really evaluating the model performance across all of these different areas. So in particle physics, which is my original background, we might think about, you want to know how your model works across the whole range of particle momentum that you could have, and you want to characterize, does your accuracy change, does your error type change across these different parts? Thinking in a more societal context, do you want to look across different, protected classes? You want to look across different geographic areas, all of these things. So really thinking about the phase space of your problem. I also see a lot of focus on transparency and documentation. We often talk about having a reproducibility crisis in machine learning and AI. And I think that applies to our scientific AI models as well. So thinking about how we can, actually meaningfully describe the data sets that we use, the models that we use. I borrow a lot from these data sheets and nutrition labels for data sets, model cards, like this AI ethics kind of literature background. for thinking about that. And then putting on my, teacher hat, thinking about my course and how I talk to scientists about these issues. I think the other thing that's not discussed enough is this idea that, well, I believe that all technology is political, and this is something that I raise to my students a lot. And so thinking about, other forces that are at play when we're building things that, we as scientists often interpret as being purely scientific systems, thinking about some of these things that Galen mentioned, like the concentration of power that's happening in the tech industry. How does that impact the questions that we ask, the kind of models that we build? How do we understand the role that technology plays in society in shaping our societal goals, the kinds of things that we put effort towards? Yeah, so I'll end it there for now.
Thank you. Thank you so much, everybody. What I really loved, to hear from, from these first comments is really how I think we are reflecting on what is our role as scientists and what we do, how it impacts society, and so how we want to think about the community that we serve, the communities that we want to reach, our students, and in general, how our role is changing. So I really love that you all reflected around this point. I'm going to go back to the slides for a moment for another very long and complicated question. So sorry about that. So I'm going to try and summarize. I was looking at this morning. I was like, why? I guess I was in a different headspace when I wrote it. But the idea here is that I was thinking about the lens of functionality or lack of functionality, how different, especially again, AI system, but as we said, not necessarily limited to AI system, right? Any model building has this issue that they may have implementation flows, they may not be robust, they may fail under adversarial attack, they may have misrepresented capabilities. So there is a whole taxonomy of failures in a way. And I wonder if sort of we can connect some of the ethical goals or challenges that have been mentioned to this idea of, can we look at how systems perform and be mindful or careful about their performance, and would this help make the connection to ethics more clear? So we can go back to our panelists now, and maybe this time Galen, I will go start from someone online. Galen, please go ahead.
Yeah, I'll try to be brief. I mean, I think that I'm probably taking your question in a slightly different way. But, I think that we are, I've been in this world, climate science, for 25 years or so, and I feel like we as a climate science community have long been attacked about being overly pessimistic and, dire in these predictions and trying to sell the world something, a hoax, something that isn't true. And I think increasingly we're now being accused of not telling the world what really was going to happen, that it was going to happen so fast, that it was going to be as bad, that the ocean heat wave that's happening right now, how was this not predicted, right? And so that's so much not an AI question, it's more a climate science question, but that's the background I mostly have. And I think that, being the best we can do as scientists is be realistic, I mean, the fact that climate sensitivity in our climate models hasn't changed in 4 decades is really because the uncertainty on that was heavily underestimated early on. And now we understand the uncertainties better, probably not fully, but we do understand it better. So in some sense, we make ourselves look bad as a community because we were over optimistic about how good our models were before. And now that we've added processes to them that were known to be missing before, we have, just said, oh yeah, we really still don't have that answer any better than we said before, even though we as a community be like, oh, but really we know it better, even though, so that kind of contrast. So I do think misrepresenting capabilities, I think remains a very important one. I'll just stop there.
Thank you. Anybody else wants to go next or comment? Savannah, yeah, go ahead.
Yeah, so I think, the first point that I mentioned phase space relates directly to robustness. I think this is one of the major kind of scientific flaws that I see in AI model building, is that we give one number for accuracy, often without even a confidence interval or something, and that really is a misrepresentation, in my mind at least, of model capabilities. And so I think, that directly relates. I think also this idea that I mentioned of transparency. So in the functionality paper, it talks about a lot of different kinds of implementation flaws that can come up in terms of maybe you didn't split your training and test data set causally, or you used a feature that actually breaks causality in your model, or different kinds of things. I think transparency on the developer and researcher side really connects to that, because I always tell my students, like, you're more likely to be able to figure out what went wrong, and if you break the robustness of your model, if you've written down specifically what you did and how you thought about doing the feature selection, doing the training setup, all of the hyperparameter choices that you tried. So I think encouraging transparency on the developer side through the whole process is very important. And then this other point that I talked about thinking about the broader socio-technical context of the problems that we do also really relates to this idea of functionality, because I think we often don't ask enough, what do we actually want our models to do? And that can be both from a science side, like how do we actually meaningfully translate the scientific question into a learning goal for the model, but it can also be broader than that, right? What role do we want this technology to play in society? How is it impacting, with climate? How are these models going to be used to impact decisions? Does that affect how we design the model, design the interfaces, decide the way that we talk about it and represent the results? So I think, yeah, all of these things. I mean, I love this paper, like, of course. So I think, I do frame a lot of my ideas in this context.
Thank you. Libby, you wanted to comment on this one? Please go ahead. I felt like.
Do we have time? Okay. Yes.
Yeah, we have time.
Okay.
Yeah.
Okay.
Absolutely. Go ahead.
So just a quick addition. I think that we've been talking a lot already about how models will be used. And I think this is one of the things that has been really hard about climate models, and that the community's been talking about for a long time, is we don't get to choose how they're used, right, once they're out in the world. And I suppose the same is true for AI models in general. We can design them for a particular use. And you brought up data sheets earlier, Savannah, and that actually 2 graduate students in my group have been working really hard to take that and translate it to data sheets for earth science data sets. And they have a prototype up if anybody's interested. And they've been workshopping this now for 2 years, saying this is really serious, we need to work on this. And again, this idea of, we cannot tell people how to use the tools we've built, but we can maybe at least explain how we hoped they would be used, or how we designed them to be used. And then the other thing, and this is maybe my positive spin on things, what is the goal of building these AI models? Again, Savannah, you brought up just some number with accuracy, 99.9% with no bounds of any sort. I guess my positive spin is, at least for me, I see so many scientists, that's not their goal. Their goal is not that final number. And I find a lot of actual hope in that, because things like transparency and robustness are no longer things that you push under the rug, because our goal is to try and learn about the system. And we don't actually feel like we get points for being wrong, if you will. So even if it's secret. And so I guess sometimes I feel like there's a lot of hope in the use of these tools for scientific inquiry specifically, because a lot of these problems and issues that we're facing, they're still very important, but almost the scientists applying or trying to learn from these AI tools don't want it to be a black box. They don't want to not have robustness, because then they won't learn the right answer. That was a very convoluted way of just saying that. I think applying these to science is showing a lot of good things.
I love the positive spin. And yeah, David John, if it's okay with you, I'm just gonna go to the next question, which is about explainability, and ask you maybe to start like on both way. And I think, here I'm really thinking about, again, when we're looking at some of the ways these AI systems, what they're destined to do, the way in which they're used, the ways in which we can fail, how can explainability limit that impact? And so please feel free to, comment on both, on what you think is, what functionality issues you're worried with, and, whether explainability can help.
Yeah, I'll try to nail the bridge and the key change here. So a couple of thoughts come to mind. One is, so there's this really great paper by Alan Murphy from 1991 on basically on the types of goodness in weather forecasts. That he came up with this really great taxonomy of different types of goodness and how they interact with each other. The first being quality, which is basically kind of what we consider accuracy is basically how good are you how good is your forecast compared with observations, and often our discussions of goodness in there, but as we've discussed in this talk, with kind of robustness and how it's being applied and all these other kinds of issues, it obviously doesn't end there, because there's also, and he mentions that there's two other types: consistency, which is like in his definition is how closely do your forecasts match the forecaster's judgment, but this can be a more generic property going beyond merely if I thought it was a 20% chance of rain and I forecast a 20% chance of rain, I'm consistent. This can be is this physically consistent? Does the AI model or the climate model's predictions match our understanding of physics, and do things link together properly? Explainable AI also kind of falls into the realm of consistency. There's not really a way to get a true explanation. We don't truly know why the model is doing what it does, other than it's multiplying a bunch of numbers together. But we can get at, is the explanation or explainability method is that consistent with our physical knowledge, and are there clever ways to test that in terms of, can we compare against other observations or other papers that have studied this in some way? Can we frame the explanation as more of a process and not just say going beyond the heat map, but also linking even do tests should if this number were high, then we would expect this thing to happen. I think that can help us get into the explanation's consistency and have a better measure of robustness. And finally, there is value. The hardest to measure, but potentially the most important component of goodness is does this forecast actually change someone's decision? If they didn't have this forecast, would they have had a worse outcome? And that's a really hard thing to measure, because it involves you need a set of users, which you may or may not know. I mean, as Libby mentioned, we want our models to be used a certain way, but once they're out in the wild, they can be used in all kinds of different ways. Then that's where I think, going back to while we have these models have a lot of potential users out there, having a few in mind that they're helping driving the conversation, I think, is important. And also, in doing so, also not just reaching out to the easiest to find users, but being more proactive in developing a broader community of users, especially those who are maybe the hardest ones to reach. I think that's a key part of making sure we build robust models. Also, running these models in a real-time setting and developing prototypes where both the developers and the users can interact with the model. My group spent a lot of time on making more interactive visualizations, and you can find a lot of cool things, but also problems by actually running it in real time. There's nothing like a good real-time experiment, which, I mean, in the weather space, of course, this works a lot easier than the climate space, but I think even in a climate context, making visualizations of the climate models is how climate scientists have discovered all kinds of issues with the models and gone back and retuned things, or else identified new signals in other patterns. So yeah, I'll stop there and turn it over to the rest of the panelists.
I love this reflecting about impact, and in a way, taking the spotlight off us, right? It's, we spend so much time making these models that sometimes it's all like, no, you have to do what I want. And I think I really love the idea of instead turning towards the people who are supposed to use them and thinking about them when we implement them as well. Yes, I know that some of you have already touched upon explainability, but if if anybody wants to add something, especially on this point, Savannah, I think you were, go ahead.
Yeah, I'll try to be short. I absolutely agree with everything David said. That is largely how I think about explainability is this idea of consistency, especially in domains like physics where we have more insight into that, and we can sometimes at least check if our models are consistent with our understanding of the physical laws that we know about. And you can do this in other ways as well. And I think this is why, working with domain experts in whatever kind of model you're building is really important, because they can sort of tell you, your model shouldn't be correlated with this particular feature or something, because that breaks causality, or that breaks, our understanding of the system. Like, there's a rich knowledge base in pretty much any area that we want to apply AI in, and we need to try to leverage that more. And I think explainability, thinking about trust building, not just in a scientific idea of trust, but also how do we build trust in end users who maybe have different technical background. I think explainability is really important there as well. Like, what can we tell people about why our models are making certain decisions? And that's more possible with certain kinds of models than others, but I think it's a really important step for public trust building, and we can probably uncover more flaws with our models that way as well.
Thank you. I don't know if anybody else wants to add a quick something. Otherwise, we'll move on to the next topic that I think is also dear to many of us. And again, if we go back to the slides for a minute. And that's, how do we run this discussion in the climate science community, which, as we know, really has people from many different backgrounds. And how do we teach about ethical AI? Or I think a theme here is really, how do we teach about ethics in climate science, whether or not AI is involved, and formally or informally. So I don't know, maybe we can put again our online panelists on screen and see if somebody wants to start. Okay, Libby, please go ahead.
Yeah, just a short point to emphasize this. Engineers, I come from a background, everybody in my family is a civil engineer but me. They always joke that they do the useful stuff and I just ask questions into the ether, right? But, in engineering, ethics is a huge required piece of that degree. Like that, you can't get an engineering degree without taking at least one, if not multiple courses, because there's this recognition that what they do, the bridge they build, the building that they put together, right? That these things really matter and can really hurt people. There can be terrible consequences. And in many ways, I think in maybe more of like, I'm going to use quotes here, but like the more pure sciences, we've thought, as Galen mentioned, oh, that's not us, we're different. We're just, quote, doing science. And I think it's quite obvious, at least to me now, that that's not the case. And so first and foremost, my suggestion, again, this is about, the question had AI in it, but first I think we need to start teaching our science classes with the same sort of engineering focus of ethics is a part of what we do. We need to be talking about where the data came from, the politics behind how did we get here, answering these questions. A lot of people talk about even what are the big questions in your field right now, and who are deciding those big questions? They're going to be different depending on who you ask for many different reasons. So first and foremost, as an educator, I would say we just need to start these discussions at the undergraduate and or graduate level in our own subdisciplines to bring everybody to the same page that yes, this is a part of science. Yes, this is lurking in the background, whether you acknowledge it or not. And then maybe potentially opening it broader, or more specifically, I mean, to things like AI specifically, or this other tool specifically. But I said it would be short, so I lied. Anybody else?
No, that still qualifies. Galen, please go ahead.
Yeah, I think I do agree with what Libby's saying. I think we need to have those conversations in our classes. But I think that raises another really important experience that the climate scientists have had, which is this question on the boundaries between climate science and climate activism, right? And so, unfortunately, we live in a world where if we do start talking about ethics in our physical science classes, then that can be perceived as climate activism, right? And whether positively or negatively, leave that aside. But just the fact is, if you've grown up, as I have, in a world where I publish a paper and I get nasty emails about people telling me I should go to jail because I'm writing about the global carbon sink, it doesn't really encourage you to go beyond the pure science and think about the application, think about what this means. Beyond telling people, well, if we want to mitigate climate, we need to cut the emissions, but that's somebody else's kind of job, and leave that aside. So I do think that that is something that we need to talk about. How do we navigate this world between climate science pure, climate advocacy, and something in between that talks about understanding how our models are going to be used, how the information can be made more transparent. And maybe not everyone is actually interested in activism or really trying to say, this means we have to do this. But that doesn't mean ethics isn't in there. But I think that there's this, there's a lot of people have sort of said, I'm just a pure scientist, I don't want to deal with that stuff because of all the negative experiences. And so, but I think the younger generation is typically not like that. And so I think that they are, on the whole, more open. And we old people need to maybe get over that a little bit. But it would be great to have more conversation and to figure out how we do that.
Agreed. Thank you. Yeah, David John?
Yeah. Let's see. Had a train of thought. I need to get back on it. I think one key thing that is driving this discussion is having a both, I think, some level, like kind of calling back to the reproducibility panel, leading from the top. So we want to see like more of our leaders in the field and different agencies basically talking about the need for ethics and encouraging and enforcing ethical decisions and principles when we're using this data and figuring out our different users. And I think we're starting to see more of that, but like want to encourage us to continue doing that, while at the kind of on the bottom up side, continue to have people hold us accountable to those ethical promises and not just throwing them out or saying it to be like, oh yeah, we're going to be ethical, and then throwing it out when the like things get challenging, and like how to. And one thing I also want to maybe also bring into the conversation too is that like climate scientists aren't the only people using climate data anymore. There's been a very rapid growth in, especially in finance, insurance, agriculture, like lots of other like major fields are using climate output, real estate, like now to make like multi-billion-dollar decisions, and not all of those groups are like employing climate scientists or working with climate scientists. They like the data is quite accessible, so that some people are just grabbing it and running with it, and there are potential issues coming up with that, with the data being misused. And if we stick to the science and aren't engaging with these communities, then it's a big missed opportunity to because a lot of this stuff is still very nascent, and like how it's going to be used and how it's regulated is being discussed now, and we need to be out there, especially the people who are experts in like all the flaws and challenges and uncertainties in these data sets. We need to be out there being like, either wait a minute or wait, this data set is more appropriate for this particular problem. So I encourage the community to work with your communities and where people are making these decisions to help make sure they're well informed and are going in the right direction, or else someone else is going to do that for you.
Thank you. I think it's a very good point. Claire? Do you mind? I want to give Savannah the chance to add to this topic, and then we are opening for Q&A, and so maybe we'll start with you and move forward. Savannah, I wonder if you wanted to add something on this topic. I know it's dear to you.
Well, I love everything that's been said. I guess I'll just add a couple small thoughts. Like one, I think a lot of these questions are scientific questions too. Like I do frame a lot of the work that I do, through a scientific lens. These questions about robustness, trustworthiness, a lot of them are scientific. And so I try to use that as an entry point, kind of thinking about what Galen was saying, like to show that this makes our science better as well. So even if you don't want to think about anything else, like we should care about that. But the other thing, to get on my soapbox a little bit, something that I really want to see, and I don't have an answer on how to accomplish it, but is a little bit of shift in sort of the hubris that I often see scientists, especially physical scientists, having, and really, encourage the idea that other types of knowledge, other fields of research are equally legitimate, valid, important, and it's worth, having our students think in a liberal arts lens, pulling in papers from other fields, building off of this very, rich space of knowledge in, ethics, science and technology studies, more recently the field of AI ethics, and I really want to see more of that, because I think, climate modeling, like any other really large, societally impactful, challenging question, requires multiple disciplines to meaningfully address it. And I think like a culture shift needs to happen around that a bit.
Thank you. Thank you so much. So we started a bit late, so I'm going to appropriate 4 or 5 minutes to have like at least 10 minutes for Q&A. We have several questions on the Slido, so feel free to add or vote for the ones that are there. Maybe I'll start with, is it Claire, right? Yeah, okay, I'll start with Claire's question and then take one from here. Can you hear? Yeah? Okay.
So this was set off by Galen's comment.
Do you mind also introducing yourself, since they are not in the room?
I'm Claire Monteleone at the University of Colorado Boulder and in Ria, Paris. And also I founded this meeting in 2011. And also for me, I kind of had to hide, or I felt like I had to hide my history of environmental activism and really come in with my AI hat. But my hope was that by bringing, so Climate Informatics, sort of the title was modeled after bioinformatics, and this idea that can we, in a completely data-driven way, study climate and maybe lend credibility, because it was sort of at the time that people such as you who were actually publishing in climate science were under attack. And so I felt that people had seen, with the rise of search engines and AI popping up in people's emails, or just even the success of bioinformatics, that data science had something to offer. And so I also avoided any policy-making opportunities or attending COP or anything to not be seen like a lobbyist or anything. And so it's interesting now we're coming full circle and finding out a lot of the biases that are in even the spatial distribution of data and how the modeling is done. But yeah, I'm hoping that bringing AI and data science into the study of climate change sort of helps the public believe you guys more. That was just an interjection that came to mind, is that, yeah, I had to kind of go underground about my climate activist past.
Anybody wants to comment on this? Should I?
Yeah, I'll just say thank you for sharing that past. I think, yeah, I mean, I think biggest picture, you know, I think that climate science is, I think of it as sort of the oncologist diagnosing the cancer, but somebody else has to decide whether we address it, right? And whether we're going to change our emissions and how we're going to adapt. And I can have very strong feelings about that, but how much is that part of my science as opposed to something separate, I think remains something that, you know, I still struggle with.
Thank you. Thank you both for sharing this. I'm going to pick a question for the Slido perhaps and then go to this one since I have one that has some upvotes. Do you think that the incentive structure of our system is appropriately designed to support scientists to address the issues of trustworthiness of our tool? Yes. Sorry, we all take a deep breath whenever we talk about incentive structure. I know that feelings rank high. Yeah, anybody? I see Savannah and Libby maybe. Yeah, I think I'll give you both a chance to say something.
Yeah, I'm going to speak more from the machine learning side because I've just, you know, I'm not a climate scientist by training. I've just started doing some projects in this space coming in from the machine learning side. So from a machine learning perspective, no, like I don't think our incentive structure is set up to support this kind of work at all. Thinking about the way that we do publishing in machine learning, it's almost entirely conference driven. The sort of standard, explicit or not, for publishing in conferences is often getting state of the art on some benchmark task, and there's so much research showing that ultimately for these sort of interesting problems like climate modeling is not really useful. So yeah, I think the entire publishing structure in this field does not encourage this kind of work. It's hard to get interdisciplinary work published. It's hard to get like negative or impossible to get negative results published. But these are the really important things in my mind to answer and address if we want to study these kind of problems. And I will say, you know, I think it's starting to shift a little bit. Like ICML this year has a positions track, which is meant to encourage more reflection. You know, we have conferences like FACT that are more looking at, you know, the kind of robustness type of questions about machine learning, but I think largely, yeah, this kind of work is not really supported by our incentive structure at all. Yeah.
Thanks. And Libby, I think you also had a comment.
Yeah, just to add to that, in terms of trustworthiness and explainability, I'm going to bring up this idea of interpretability. You can define it however you wish, but the idea of actually from scratch building architectures that make sense to the user in their steps. And I often like to use like a decision tree as something you can really trace back. And yes, at the end of the day, it's just multiplying numbers with a few extra functions in there, but really building models that sort of think like the scientist thinks, if you will. And I know a few people on this panel have done work like this before, but I'll reflect on one graduate student of mine working in this area. It's slow work. It was fantastic. I loved it. It's probably one of my favorite projects I've ever gotten to work on because there was creativity. It wasn't just taking something out of the box from somebody else. It was building in our physical knowledge of the system, but it is slow. And our best case scenario was it would probably do about as well as the off-the-shelf box. But we understand this one. And in terms of a publishing incentive structure, that was over 2 years of work to get this one model that we're really proud of. But you know, that's one paper, maybe, if the reviewers like it. So with that in mind, I think this is maybe, I'm saying, is specific to AI. Now, there are other climate problems that are slow, that take time too, but I'm going to actually point out this one as being somewhat specific to this discussion, that if we want to go beyond, as David John said, the heat maps and building models that we really can explain every step of the process, we're going to have to slow down because these don't just happen overnight. And I'm not sure how we're going to do that though. Okay.
Thank you. Oh, yeah, sorry.
Yeah.
John, you have a quick comment. I want to make sure we have some time for questions, but please go ahead.
Yeah, one thing I want to build on with the I guess incentive structures. I mean, I think good incentives are definitely important, but they're not the only game in town. There's people are not only driven by incentives. There's a lot, especially as scientists, there's a lot of inherent curiosity or the desire to want to dig in on the problem, that kind of intrinsic motivation maybe. I think creating environments where it's possible to explore these threads is really important, because often that's where a lot of the new insights come from, is just being able to give people the time to really, like as Libby mentioned, do the slow work, build the thing from scratch, and not just pull off the off-the-shelf stuff. Not that the off-the-shelf stuff can make it easier to do some of this exploration. Don't get me wrong, we use that quite a bit. But I think, yeah, just like finding ways to recognize and reward curiosity, and maybe think about the quality of papers in addition to the quantity, and might help with the situation.
I love this. Thank you. Well, go for a question in the room.
Hello. It's Dan Giles from University College London. So I just wanted to pick up on a point that was raised yesterday.
Can you speak just a tiny bit louder?
Yeah. Hello. Can you hear me?
Yeah.
Yeah. It's Dan Giles from University College London. I wanted to pick up on a point from yesterday's reproducibility session, and it was also kind of touched on the privatization aspect, which is the ethics around compute capacity. So obviously some of these models take a lot of compute to train, which is one aspect, and not everyone has that access. But secondly, also from more like a climate perspective, we're producing a lot of data, and not everyone has access to the processing power of that data too. So should we start thinking about, what's the ethical implications on that? Obviously global south, that kind of thing as well. So people had a take.
Galen, I think.
Yeah, I totally agree with that. I just also want to add that one way that we can be more ethical in our work is to be open and provide the software that we're using and to make it easier from that reproducibility standpoint. But the incentive structures really do not exist for us to do that work, right? We want to get, even if it takes 2 years, like Libby was saying, to get that project done, the student wasn't incentivized in that time to also create software, beautiful software that is easily usable by somebody else, right? They're just trying to get it work and get their PhD completed, right? If now you want to turn this into something that the next person can use, which would be a good thing to do, you have to pay somebody else another 2 years to rework the software, or a year or something, right? So we've tried some of this in my group, and it's hard and it takes a long time and it's useful, but that is also part of these incentives not being adequate for what we're trying to do. So it'd be great to have more support for that.
Agreed. Yeah. Go ahead.
I kind of have mixed feelings on the compute structure side, because on the one hand, I think there can be a lot of value with being able to see what we can do with the large compute, and build models that can then be often run with a very small amount of compute in a lot of different contexts. And there's also, I think, a lot of other science, on computational science, there's a lot of emphasis on making everything run on as many places as possible. It's like, if you're, say, doing more, not everyone's going to have a giant super collider, particle accelerator in their backyard. There's some science that is not easy to be made accessible, but should still be done, because it's, I think, important to answering lots of different key questions, and that's, I think, one of the reasons why we should invest in large compute. That said, I think this gets into what are we optimizing the model for, and accuracy isn't the only thing we should be optimizing for. Latency is a key thing. Making a smaller model that works well enough basically is probably more broadly usable and easier to debug, and has a lot of other benefits, and is easier to like embed in different applications. So I think making sure we're not just like balancing that accuracy and efficiency and latency and robustness, and looking at having a more holistic view of metrics will help, I think, like balance out the desire to just keep getting more and more compute, and I hope drive research in other directions.
Thank you. I love this discussion. I really wish we could continue. I wish we could have, a panel just on incentives right now, but unfortunately we have to be mindful of your time and your right to lunch and our panelists' time. But let's give a round of applause to all of them. I hope